Welcome back, students. Today in this session we are going to see few applications of the electromagnetic waves. Already in the previous session I have shown you the electromagnetic spectrum, which actually ranges from gamma rays to the radio waves. So here I am going to individually explain what are the different applications for the waves. So to begin with, the radio wave. The radio wave is one of the popular electromagnetic wave that we know for a very long time. So these electromagnetic waves actually serve a very important purpose in communication during early 1900s. So radio wave is produced by accelerated motion of charges in conducting wire. First point, they are used in radio and television communication systems. They are generally in the frequency ranging from 500 kilohertz to about 1000 megahertz. The AM, which is nothing but amplitude modulated, the band is from 530 kilohertz to 1710 kilohertz. Higher the frequency, up to 54 megahertz are used for short wave bands. TV wave ranges from 54 megahertz to 890 megahertz. See, you don't have to remember these numbers, but at least you should know approximately under which range it falls. You see, AM actually falls between 530 kilohertz to 1710 kilohertz, okay. But the TV waves ranges from 54 megahertz to 890 megahertz. So the waves that we get for our television is actually has got some higher frequencies. The FM radio band extends from 88 megahertz to 108 megahertz, which is a bit less than the one which we receive for the television. The cellular phones use radio waves to transmit voice communication in the ultra high frequency bands. So that is completely different. Okay, even our mobile phones use this, but they operate under ultra high frequencies. Okay, those frequencies are not easy to detect. These frequencies could be easily tapped using a LCR kit. If you are aware of it, even a school student who will be able to build an LCR kit could actually probe this down. But tapping a mobile phone signal is not easy as you tap the radio signals. Now coming to the microwaves. Microwave is not a term that you haven't heard about. In fact, we have an electrical appliances under this name which we actually use to cook food. So what exactly is the microwave? See, it is the shortest wavelength of a radio waves with frequency in gigahertz. A frequency is bit higher than the radio waves. Are produced by special vacuum tubes. Due to their short wavelengths, they are suitable for the radar system used in aircraft navigations. Radar also provides the basic for the speed guns used in the time fastballs, tennis serves and automobiles. The microwave oven are an interesting domestic appliances of these waves. In such ovens, the frequency of the microwave is selected to match the resonant frequency of the water molecules, so that the energy from the wave is transferred effectively to the kinetic energy of the molecules. The rise in the temperature of any food containing water, which means microwave is actually passed into a food material which actually have dipoles in them. Dipoles are nothing but the water molecules. So this microwave actually make them to resonate at very high vibrations. They make them resonate to a very high vibrations, so that intact produces huge amount of temperature. So that temperature is actually utilized to cook the food. Okay, only if a food product is going to have some water content in it, then that could be cooked using the microwaves, otherwise it is not possible. Clear? So moving to the next one, infrared waves. Infrared waves are produced by hot bodies and molecules. Okay. You could have heard something about infrared cameras. Through that, we can even see the body which is emitting thermal energy. Okay, that is the reason why we can even see through walls, because walls are the ones which don't carry enough temperature, but whereas our human body, each and every part of our body has its own individual temperatures. So, if a person is going to stand inside a room using an infrared camera, it is easy for us to detect a person using his own body temperature. This band lies adjacent to the low frequency and long wavelength ends of the visible spectrum. The infrared waves are sometimes referred to as heat waves. This is because the water molecule present in most materials readily absorb infrared waves. Many other molecules, for example CO2, NH3, also absorbs infrared waves. After absorption, their thermal motion increases, that is, they heat up and heat their surroundings. Infrared lamps are used in physical therapy. Infrared radiations also play an important role in maintaining the Earth's warmth or average temperature through the greenhouse effect. So, this is again a very important thing. So, now we move into the visible rays. It is the most familiar form of the electromagnetic waves, because whatever we see with our naked eyes are the visible rays. It is a part of the spectrum that is detected by the human eye. It runs from about 4 into 10 power 14 hertz to about 7 into 10 power 14 hertz, or a wavelength range of about 700 to 400 nanometers. Visible light emitted or reflected from objects around us provide us information about the world. Our eyes are sensitive to this range of wavelengths. Different animals are sensitive to different range of wavelengths. For example, snakes can detect infrared waves, and the visible range of many insects extends well into the ultraviolet region. See, our human eyes are not capable of detecting the light beyond the visible regions, not below or not above, whereas other predators like snakes and few insects or few reptiles has a capacity to even detect the electromagnetic waves of higher ranges. Okay. So, ultraviolet rays, it covers wavelength ranging from about 4 into 10 power minus 7 meters or down to 6 into 10 power minus 10 meters. It is close to an Armstrong unit. The ultraviolet radiation produced by special lamps and very hot bodies. The sun is a very important source of ultraviolet light, but fortunately most of it is observed in the ozone layer in the atmosphere at an altitude of about 40 to 50 kilometers. UV light in range quantities has harmful effect on humans. Exposure to UV radiation induces the production of more melanin, causing tanning of the skin. UV radiation is absorbed by ordinary glasses. Hence, one cannot get tanned or sunburned through the glass windows. So, it is very simple. First point comes from the sun. Yeah, of course, it is harmful when you get directly exposed to the ultraviolet radiations. So, it is being filtered through the ozone region, but in recent times we actually constructively use these ultraviolet rays in order to kill few microorganisms that are present inside our water. See, they actually expose our drinking water to the ultraviolet rays so that it kills few microorganisms inside that, and it makes the water suitable for us to drink. So, these are few constructive purposes in which your ultraviolet rays could be used. So, now we move into X-ray. X-ray is not a new term for us, because any person, any human being who exists would have gone under the X-ray at least once in his lifetime for few medical purposes. See, beyond the UV region of the electromagnetic spectrum lies the X-ray regions. We are familiar with X-ray because of its medical application. Yes, of course, it covers the lengths from about 10 power minus 8 meters down to 10 power minus 13 meters. One common way to generate X-ray is to bombard a metal target by high energy electrons. X-rays are used as a diagnostic tool in medicine and as a treatment for certain forms of cancers too. Because X-ray damages or destroys living tissues and organisms, care must be taken to avoid unnecessary or overexposure. See, it could cause cancer, at the same time it could also cure cancer, depending on how you expose the X-ray to. See, if there is a cancer cell is a bunch of cells which have already dead. If you expose enough amount of X-ray to the cancer cells, it will be very helpful for us to burn out the cancer cells. It will not cure completely, but it helps us to reduce the amount of cancer cells that are present, which in fact reduces the spread of the cancer cells. On the other way around, if you are exposed to the X-ray, as we have already seen, it has got a huge amount of frequency. So, the energy of the X-ray is also high. If some good healthy cells get exposed to X-ray, that in turn dies and becomes cancer cell. So, you can produce cancer or you can also treat cancer using X-rays depending on how we are going to use it. Next, gamma rays. They lie in the upper frequency range of the electromagnetic spectrum and have wavelength from about 10 power minus 10 meter to less than 10 power minus 14 meter. This high frequency radiation is produced in nuclear reactions and also emitted by radioactive nuclei. They are used in the medicine to destroy cancer cells. Okay, the tabular column which I am going to show you in a short while will summarize the different types of electromagnetic waves, their production and detection. As mentioned earlier, the demarcation between the different regions is not sharp and there are overlaps. Okay, so this is the tabular column that I was talking about, which will give you the range under which the different spectrums are going to fall under. You see, radio, microwave, infrared, the visible light, ultraviolet, X-ray and gamma rays actually falls between few wavelength regions which obviously overlaps. So, with this we come to the end of this session. So, this is actually straightforward. Whatever we have learned today is pure theory. You might wonder whether we will get any question based on this theoretical application. Yes, of course you will get, because if you go through previous questions being asked in this particular chapter, you could see there are plenty of theoretical questions being asked based on the application of the electromagnetic spectrum. So, that is the reason why I strongly insist you to go through the applications. So, with this note we come to the end of this session. In the next session, I will show you how the numerical problems are being dealt in this chapter. Thank you.